Welcome to the Dev Banner. This is Eric. This week's how-to video is on arrays, slices, and maps. Now, maps and arrays you're going to find in most languages, but slices are pretty unique to Golang. And we'll talk about the differences between slices and what their work with is arrays. So data structures help us organize and retrieve and work with maybe mount a lot of data within our program. So if you've seen my other videos, you'll see that I use this parse input and clear screen to help visualize and help you viewers see what's going on as I run these demos. So I'm going to start with demo array. And let's go ahead and run the program. And we're going to just walk through it. Arrays are declared and initialized in a couple ways. Line 37 and also line 47. Now, you'll see the difference with slices, but arrays, you give it a size that you want. And at that point, array becomes immutable. And although you can change the values within that set of arrays, you can't change the size. So as you see, I put 2, so there's 5 cubby holes in this array, if you want to think of it that way, cubby hole. And in the third one, in the middle, or I should say the second one, I apologize, is I put a 2. And in the fourth one, I put a 4. And like everything else, when we instantiated this array and declared it, the rest of the ints, the values that were put into the array, the type here, was set to 0. Now on this one, with the array of strings, I had 3 spots, but when I instantiated, I told it to fill in the first and the second indexes, or I should say the 0 and the first index, with the words 1 and 2. And then obviously after I print it all out, it's empty, which is the string's default value is an empty string. And then I set it to 3 and I print it out just so that you can see. And those are arrays. I personally don't use arrays hardly ever use them. What I do use is I use slices, and slices are like arrays, but they can expand, and you can add to them, and that's with this keyword called append. So the difference is I don't give it a number when I initiate it and declare it, and here it looks about the same as the other one, as arrays. It looks really similar to this, but I don't give it a number, and so I'm basically saying, hey, this is a slice. And then we use this built-in function called append, and append takes an elements, as many as you want. That's what this ... representation is saying one or more of this type. And type here could be anything. Just like an array, you can have an array of ints, array of strings. You can have a slices, arrays, strings, or even like structs. So any data type you can have an array or a slice of. And so then that's how you append it. So this S1 is an array, a slice of ints, and I'm going to add a 1 to it, and I print it out right here. And I have this little helper function called print slice info that will just do these 2, so it looks pretty familiar. And I'll go over that here in a few minutes. And then I made a slice of strings and filled it out. You don't have to do this. You can just start it off by nothing. But I pre-filled it in with, as I declared it, with some values and print that out. Now, what's really nice with an array, with a slice, is you can make another slice of your slice, or actually you make a slice of an array, and I'll show that down here in a minute. But this little syntax is done by before the colon is the first index you want to start off with, and the second value after the colon is what index you want to end on, but not include up to. So if you left it out, you're basically saying, give me a slice of everything. But in this case, I'm going to do a 3, which gives me 1, 2, and 3. So once again, give me up to 3, which is 0, 1, and 2. And so I made a slice from that slice and give me the first 3. Now, as you can see, I left the first one out, so it just basically said, give me the first start at the first and give me up to a number. This one is start at the 6th index and go till the end. And so when I did that, so 0, 1, 2, 3, 4, 5, 6, and then give me to the end, you get 7, 8, and 9. Now, what's really interesting is every time I take a slice, I'm going to make a new slice out of it, but it's really just a pointer to the underlying slice or array that you're getting it from. And then what makes it really nice is you got this extra metadata that's not on arrays. Technically it is on arrays, but you mostly use it in slices to get a length or capacity, and it's used to help from this pointer, the start of the slice, what the length of your slice is and what the capacity is. And so in this case, if we look at this 1, 2, 3, it's actually length of this 3, but its whole capacity is the rest of it. Now on the 7, 8, 9, you'll see that the length is 3, but the rest of the underlying slice is only 3, so your capacity is 3. Whereas you do the 4, 5, and 6, which is this right here, 3 to 6, you'll see that the length is still 3 because that's all you're looking for, but the capacity is 6, meaning that if you really wanted to, you could change. Well, it gives you the capacity of the underlying, what's left of the underlying slice or array. So going on, I make an array, and I'm just showing that we could take a slice of that array, and that is S6. And then here's some examples of just creating another slice, just a random slice, and then appending it. And like I said, you can append more with that dot type, and that's done individually, or you can give it another slice and you can unpack it and with the dot, and it will do the same thing. And so as you can see, I start off with the 12, 13, 14. Then I added on line 84, 20, 21, 22. And then I appended S6 with 2, 3, and 4. And as you can see, each one of those then makes a new slice in memory and gives you a new pointer to that underlying slice. So those are slices, and they have the same rules. You can't go above or below the index of what the length is, so you're always looking out, hey, what's the length of this this array or slice, so that you don't get into a panic mode and your program doesn't panic because it's out of index. So those are slices. So let's go to maps. And one difference between a map and the other ones is if you just say, hey, give me, I'm gonna declare an array, or I'm gonna declare with a variable a map, and it's basically a map is a key value in memory store. I think in Ruby it's called associated arrays, in like C# or C++, sometimes you hear them as dictionaries, but you have to use in Go, if you instantiate it or declare it like that, this is how you instantiate it, and is with this make in built-in function called make. And you can pre-allocate it with a size, but I typically don't, I typically don't do that. And then you just give it a key of that type in the brackets, and the value is that type right after the brackets. Or you can do this, which is I think is a little bit more convenient and a little bit straightforward. And so that when I work with maps, this is pretty much how I do it. And basically you just do the same thing. You give it a key and give it a value, and if you redo the value, so right here I am printing 2, 3, 4. If I came through and I said M2 4, and I went like 24 or something like that, and I reprinted this out, 4 would turn into 24. I hope that makes sense. And I am printing it, but I just want to make mention that in maps printing, Golang came out and said, working with maps, it could print, if you just print out a map, just like we did here, you can get it in any order. It's pretty random. So it doesn't really matter when you add them to the underlying data structure. You print it out and it could be random. Whereas arrays, it's going to print in order that the index is. So as you saw before. And what's really nice with Golang is that they have this really cool signature on when you just say, hey, give me the, go look for this key within this map. This first return argument value is the value, and if you give it a second one, that becomes a Boolean, and that will tell you if it found it or not. So it's an easy way to say, hey, does this exist? By this key, is there a value? Now, once again, if you're not going to use a variable, then you can use underscore, but this case is the value for this key. And since I do have a 4 in there, this should print, well, it should just print this information. And then there's another built-in function called delete. You give it the map of whatever you have, and then the key, and it deletes it. And so here, I'm just doing the opposite as 105 and 106. And I'm saying, hey, if it's not there, go ahead and print that message, which is these two outputs. Then let's see, I'm just doing an int string now, and just to prove my point, I'm saying, hey, give me the index, the key of 2, and it prints out 2, and give me index of 4, which there is no 4, or the key of 4, I should say, not index, and it's not found. It's empty because it's a string, right? And default strings are empty strings. So you wouldn't really do this. You would mostly do that just to prove. This doesn't tell you other than, is it there or was it really empty? So I really like map. I use it in memory. It's really fast to find things by that data structure is really easy to find the key, the value for a particular key in the underlying data structure. And so I really like that. And so going on, let's go to sorting. I'm gonna go ahead and press enter. And I created a slice here, has some random integers. So Go gives you a package called sort, and one of the functions is hey, I'm going to sort ints, and it takes a slice, and I said and S1, and then I told it to sort, and it kind of does it in place and replaces everything, as you can see, from the address. It's the same memory that's pointing to that, and so everything is ordered correctly. Now you can sort an array of structs by one of its variables, one of its fields. And so I have this simple person struct with a name and age. And all I do is there on that sort package, there's this slice, and it takes a function, it takes a slice, and it takes a function that acts like a less. And I'll explain less here in a minute. But basically it says, hey, as it goes through each one of the elements in the slice, it assigns this to I and this one to J, and it says, hey, if I is less than J, great, I'm gonna go on. If it's not, if this becomes a false, then it's gonna swap it. And so as you can see, I created a printout Joe 20, Nancy 12, and then I tell it to sort.slice and slice it by, or sort it by age, and then that gets sorted. Now there's a second way to do this. It's a little bit more, I should say, more involved, and it goes along with, I'm creating a type of array of persons, and it's called age by age, just descending. But you have to give these three functions, methods I should say, on that struct. And length is one, swap. Now this is a really cool way to swap two indexes in one shot, and that is to assign J, B of J to B of I, and B of I to B of J, and it just knows how to make that done in memory, and it's pretty cool. And then this less, so this less looks pretty close to this one, but in this case I'm going to do less than, and instead of I here I'm going to do J because I want to descend now. And so by doing that, I'm calling this sort of sort, and it wants, sort of sort wants a sort interface. If you know anything about interfaces, or I guess if you don't know anything about it, just, I'm going to make a video about them, about interfaces, but just know that if my struct has these three functions or methods on them, I should say, then I can pass in that type. So I'm basically saying, hey, this person descendant is an array of person, but I'm going to cast it as this type, and I'm going to set it to the sort function, and then it's going to sort it descendingly. It's a little bit more advanced, but I just wanted to show you sorting on slices. And then my print, this is just generics. Generics were introduced in 1.18, I believe. And it's been for a long time, people like, where's our generics? And all this is saying is, hey, any type of T can be sent in this function. And all I'm saying is I want a string called who. That's what this S1 or this person is. And I need a slice of that type, whether it's an int or a string. And then I do some printing. And length and capacity are built-in functions that give you, just they're little helper functions. And so that's where this stuff comes in. So that is arrays, maps, and slices. And I hope that was useful. See you next time.
Please subscribe to the channel and make sure notifications are turned on.